Welcome everyone to Do You Really Want Your VFD to Be a Pimp Wear Out Maximizer? I'm joined here by Bobby. We're both based in beautiful and sunny Montreal today, where for the past 6 years, SmartD has been on a mission to revolutionize motor control, and through the latest breakthrough in power electronics, bring you the first completely filterless low harmonic VFD that also brings a sine wave to the motor. And so today we're going to talk to you about what might sound utopic, but a VFD that is not a threat to your pump's lifespan. It is real, and today, with the help of Bobby, we'll walk you through how our drive works, how a PWM impacts a pump, and we'll bring you proof of these impacts. So Bobby, if you want to start us off, is a PWM pulse width modulation or pump wear out maximizer?
Thank you, Simon. Good question. So most of us know basically what is a PWM signal, right? But it's actually started 40 years ago with a standard VFD architecture, basically AC rectifier to DC bus and a AC inverter, so AC-DC to basically control the speed and the torque of the pump by varying the frequency and voltage of its power supply. Okay. What exactly is a PWM signal, a pulse width modulation? The method is actually represent a square wave or rectangle wave pulses to vary the duty cycle. So by changing the duty cycle, you actually changing the power delivered to the electrical signal. In an inductor, by modulating the voltage as a series of pulses, it's actually generating a pseudo-sine current to basically going to the motor and the pumps, okay? And then the output is actually generating by what we know in the architecture, a silicone base, insulated gate bipolar transistor, IGBT. So that's the technology that is actually came out in the 80s. So IGBT is turned on and turned off rapidly to create a series of pulses that mimic, again, the sine wave signal, a form that is actually sent to the motors, known as the pulse width modulation, PMW signal. But the signal is actually have impact on pumps and motors. First is the AC motors that using the pumps is actually designed to work with a sine wave signal, not a square wave or rectangle signal. So the PWM signal is causing the motors of the pump to overheat. Of course, we basically, over the years, we came up with mitigation solution for it. So we can actually put a sine wave filter, so converting back from the square wave signal back to a sine wave signal. But in addition to basically the pulse width modulation, the way that it's generating in the VFD, at the edge of the signal, is actually have a lot of disturbance or spices, voltage spike. And that is actually due to the switching characteristic of the component, the load, and the physical layout of the circuit itself, okay? And over long cable, especially, can damage your motor's insulation and as well the cable. And the cable is actually a safety risk. If you have damages in the cable, known as coronary discharge, basically damage the jacket and insulation, that is actually gonna expose the cable, the live cable, to the operator. So that's actually is a live threading safety issue. To mitigate those problems with insulation of the motors or the cable, we actually can propose to put in DVDT filters, again, just to reduce the impact of the voltage spike, and inverted duty motors to be able to sustain the voltage spike going basically from the VFD to the motor. And of course, make sure that you have special insulated, basically shielded VFD cables, so that is actually resolve the problem with the coronary discharge. But again, one of the things that PWM, the signal coming out, and people don't think about it, is actually the 3 output signal of the IGBT going out is generating what's known as a non-zero voltage, and it's a common mode voltage. A common mode voltage is the sum of the 3 phase signal divided by 3. So that's the mean of it, the average. And most of the time, since they are not synchronized, actually is having a non-zero, and as is shown in the basically illustration that we have on the right. Okay, and the problem that gonna be basically causing to the motors or the pump is actually what is known as a shaft voltage. So common mode voltage is between the voltage going to the VFD to the ground. That's common mode voltage. That is actually the motor seeing it, but it's actually gonna induce what we know as a shaft voltage. And the shaft voltage is actually going to the shaft of the motors. And what is the best way if you have a voltage? It's actually gonna have a current, so that's the induced current, shaft current, and where that's gonna go to basically go to ground. And the fastest way for the current to go in is actually through the bearings. So PWM signal, common mode voltage, is actually generating the induced bearing current, and they can cause basically failure. Okay? So the failure is actually due to heating, frosting, and fluting. That's basically the electrical arcs that's created in the bearings and causing that in. Over time, is actually causing bearing failure. So again, mitigation, we basically came out with some mitigation for that. Common mode choke, that has actually helped to eliminate the common mode voltage. Have insulating bearings, again, just to prevent the current to go through the bearings and go to the frame instead. And of course, you have the shaft grounding rings. That is actually helping as well to basically not having the current go straight to the bearings and the balls, and installation is going through the frame. Okay. Now, Simon, I'm pretty sure that when you talk about the VFD, right? Is there a VFD that can help pumps run less stress, cooler, quieter? And do you have any data to show it?